right. Good morning, everybody. Happy Friday. Today is February 13th, 2015, and this is Before the First Cup with Jules here on UCY.TV. Oh, it's Friday again, and that is awesome. It is a balmy 3 degrees here in upstate New York with light snow and cloudy skies. It's freezing here. At least we don't have any more snow, but I see we are under a lake effect snow watch this whole weekend and through next week. I don't know. Tomorrow I'm supposed to get up into the 20s and then plummet back down to sub-zero temperatures. I don't know what's going on up here, but like I say every single day, I have about had enough of winter. This hibernating is not doing me well, that's for sure. Getting a little bit stir crazy, but that's why we've spent almost a month now talking about nanotechnology and crazy mad science gone mad. Yesterday we ended up, I don't even know where we ended up. We were looking at, I know we looked briefly at the Calico Project by Google, some of this immortality medicine that a lot of the large corporations are involved in. Our government's pledge for $1 billion in funding for the Brain Project. Being able to create self-assembling nanobots that now they're going to use for a cancer cure. Step right up. So today, and DARPA's Biological Technology Office. So today, what we are going to get into is nanotech in food. And there's actually a few things that we're going to touch on here. Not only nanotech and food, but a connection between nanotech and GMO. And I've had my suspicions for quite a while. I've talked about Dr. Huber, and I actually found that clip that I've been meaning to play for you for ages on end now, about the new quote-unquote life form that's been found in the soil around GMO crops. I dug into another video for about an hour this morning. I listened to it. It was pretty long, though. But there's a woman that knows Dane Wigington as well as Francis Mangle. We've had him on a few times. He was the soil engineer out of Northern California that has been doing readings for like 40 years of the soil and has been finding all kinds of aluminum uptake, barium, and different things like that. The lecture that I was listening to actually had to do with chemtrails, but she delved into an area where she started talking about Morgellons. And, I haven't done enough research into Morgellons. I dug into it when it first appeared on the scene, but I kind of forgot about it until now. And as I was watching this lecture this woman was giving, and she was very well researched, and she was talking about the nanofibers and some of the findings that Dr. Kornikarn had found in air sampling and sampling of some of these objects that were coming out of people. It really struck me, guys. I'm going to tell you, everything she's talking about are things that they're working on in nanotechnology. So now I'm really kind of freaking out over this whole symbiosis that's going on. I mean, I've been telling you about how this whole thing that's going on now is we are literally being usurped by corporations that are, and our government, DARPA included, and all the universities that are getting funding, that are doing research, maybe wittingly or unwittingly, to create synthetic biological organisms. I really, really think, beyond a shadow of a doubt, that is absolutely what is going on. When I started getting into nanotechnology in our food too, there's a whole bunch of manufacturers that off the bat have are well known to be using nanotech, if not only in their food, in their packaging as well. But this is off the hook now. So I'm trying to figure out where to start. I have quite a number of clips here, and one place that we might start. Actually, we might finish here. I'm not going to start here. We'll finish here. Let's start actually with this Australian clip that I had found. And Australia is one of those countries that's kind of a test bed for New World Order technology. The one thing I have to say about Australia, despite the fact that they are very socialist, is the fact that at least they have GMO labeling and we don't. Whoops, but I hit the mute. But the one thing that I discovered is that Australia at least is arguing over whether or not putting nanotechnology in food and not labeling it as a good thing. And this was really the only quote unquote mainstream type video that I have found. It's a news report where they talked about this. So let's at least listen to this. It's called Nano Food, nanotechnology in food. I promised 4 weeks it took me to get here, but here we go.
Technology is a term that gets bandied around a fair bit. The promise of longer-lasting bread, super low-salt soy sauce, even Kraft Foods' interest in a smart blob that can be made to taste like anything using nanotechnology have all been part of the highly speculative future of nanofoods. But what about here and now? How many of these foods already have nanoparticles in them? And what do we know about the harm they might cause? Well, the answer to both questions is we don't actually know. The term.
And I'm going to stop for 1 second. That is the truth. They don't know. I dug into some very scientific documentation that's been presented at a federal level, and many of the scientists are crying foul because nanotech is so small. We talked about the definition of nanotechnology. It's at a subatomic level, and they are able to go in and make scientific synthetic living organisms that they can manipulate that are so small that they can not only pass the blood-brain barrier, but they accumulate in all of our organs. So that's one of the issues that they're talking about here. Though, and I saw a story this morning, and I've been saying this for a long time, but they've been messing with nanotechnology in our food since the early 90s, and we don't know about it.
Nanotechnology is used to describe engineered matter that's generally less than 100 nanometers in size. In other words, 1,000th of the thickness of a sheet of newspaper. Nanoparticles already naturally exist, for example, proteins in milk or ash in the air. But building nanoparticles into food or its packaging can change its nutritional value, lifespan or appearance. Titanium dioxide is the most commonly used nanoparticle in food as a whitener in powdered sugar, coconut and yogurt, also in sunscreens. Dr. Ricky Yada is a leading researcher into nanoscience in food technology. He's at Sydney University to brief Australian food industry experts on the rapidly expanding global field.
Well, there's a number of benefits that nanotechnology could bring in the food area. For example, the delivery of nutrients at a much more lower level.
But right now we don't even have a way to test for nanotechnology in food. And there's inconclusive research on both sides of the debate over their harm and benefit.
That's one of the concerns. What is the long-term effect of consuming products that have nanoparticles? You know, because of the size of these nanoparticles, because they're so small and they can penetrate membranes and tissues, there is some concerns of these nanoparticles accumulating in tissues and organs, and will that have a detrimental effect to the consumer who consumes that product?
I'm going to stop again for a second. So I still have the story open. This is out of UCLA from 2010. And they even say the exact same thing. Non-biodegradable, bioaccumulating nanoparticles are likely to have a number of effects in the body. If they are taken up by macrophages, they would likely trigger free radical release, which would result in cell damage and inflammation. And if they accumulate in the lysosomal compartment, they cause toxicity. A large portion of the nanoparticles, either accidentally or deliberately introduced into the body, will end up in the liver, and accumulation in the spleen, intestine, bone marrow, lymph nodes, and brain are also shown to be possible. So let's just launch all this stuff in our food and have no way to tell whether or not it's in there.
SANS, or Food Standards Australia New Zealand, says it's not received any applications to approve new or novel nanoscale particles for food use.
Right now, jurisdictions around the world are struggling with how to regulate nano products. Right at this point in time, no products have actually been approved for nano release.
But Friends of the Earth estimates there's now hundreds of food products available in Australia that may contain nanomaterials.
Hold on one second. I want to back up there because they actually list a whole bunch of the products. Let me just bring the screen up. Chocolate, which we know about. Nestle, I believe, is one of the corporations. I got a list. Hold on. Let me hit this again. This goes too fast. All right. Chocolate, popcorn, suckers, cookies, chewing gum, coffee creamer, yogurt, mayonnaise, crackers, salad dressing, pudding, pasta, oils, cream cheese, mints, donuts, breakfast cereal, chocolate syrup, and sports drinks. Now, the ones that I was aware of and I've talked about with you guys before were salad dressings and mayonnaise. I knew about chocolate. I've heard about that each time Halloween comes around, and now I found proof of that, but I didn't know about any of this other stuff. So that's pretty freaking Looney Tune. This was as of May 2014, this study came out.
Without any doubt at all, there are nanomaterials in food contact materials, and in agriculture already available in Australia. Foods to which children are exposed, such as Mentos, donuts, M&Ms, and Cadbury's chocolate, we have no idea what is on the market here, and we have no idea what their impacts are. And it is our regulators that are responsible for tracking that and regulating that, and they're just not doing it.
We contacted Mars Australia for comment and were unable to find a local spokesperson for Mentos. For their part, the companies deny that they use nanotechnology in their products. Meanwhile, in the void left by little or no regulations, brands are being slippery about their definition of nanotechnology.
There's a basic assumption I think you can make that if there are new or novel ingredients in food, then the onus of proving that the food and the ingredients are safe should rest on the manufacturer and on the regulator.
Remember the whole GM debate? That was when consumers pressured food manufacturers into clear labelling. So at least while there was ongoing research, they could know what was in their food.
You know, with GM, we debated for the longest time at what level did that GM or gene have to be at in order for us to label it genetically modified. And I think we're going through those same debates again. The consumer's right to know what's in their food supply system. And again, that's a debatable topic right now.
While part of the problem is that nanotechnology particles are a relatively recent addition to the food stream, the other part is that we just don't know which ones and what they might be doing.
And there you go. And it's the absolute truth. I mean, the genetic modification, like I said, in Australia, they already have labeling laws, which we don't have here. But he brought up a good point. You know, we have a right to know what's in our food. And a lot of these companies, and I've mentioned this many times before, they have their own research departments where they are doing this research without any oversight. And I want to read the story that I found on foodispower.com. Overview of nanofoods. Nanoparticles are now being used in hundreds of consumer products, from potato chip bags to baby foods, and even some fruits and vegetables are treated with a nano coating to lengthen their shelf life. But even though nanoparticles have been used in food manufacturing for decades, and I found an article this morning that it said since the early 90s, which I knew I'd read that before, no one really knows how prevalent they are, because just like GMOs, the FDA does not require companies to label nanofoods or even to report their use in food products. However, nearly 20 of the world's largest food manufacturers maintain in-house nano food labs, including Nestle, Hershey, Cargill, Campbell, Sara Lee, and Heinz. And some industry experts speculate that 40% of food products in the U.S. will contain nanoparticles by 2015. Ding, ding, ding. We're there. Nano environmental impacts. One of the ecological problems with nanotechnology is that certain types of matter that are stable on the macro scale can be volatile on the micro scale. Hold on, I got to disconnect. For example, antimicrobial properties of nanoparticles can disrupt signals between bacteria and plant hosts and transmit contaminants, which endanger the entire ecosystems. And that is right along the line of what Dr. Huber has been talking about from what he's been finding with the stuff that's in the soil around these GMO crops. Studies have shown that nanosilver particles used in food packaging can interfere with an organism's DNA replication. Nanoparticles are so small that sewage treatment cannot filter them out when they are washed down drains, so they enter the aquatic ecosystems where research has found they can kill and mutate fish embryos. In 2008, government scientists with the National Research Council released a report charging that the FDA, the EPA, and other federal agencies responsible for regulating nanotechnology do not have an adequate plan to determine whether it endangers the environment or human health. Notably, just as the early purveyors of GMO claim that their technological advances would increase food output while reducing pollution, so do nanotech advocates insist that their methods will produce food and other products more efficiently and cleanly by conserving natural resources. However, critics point out that nanotechnology production requires excessive amounts of water, energy, and toxic compounds. Clearly, those who stand to make fortunes from GMO and nanofoods have a strong economic incentive to accentuate the positive aspects of their technology while de-emphasizing the dangers. I was just reading a story, too. Just about every major country on this planet right now is dumping billions of dollars into nanotech research. And they're all racing to be the first ones that come out with the next newest big thing. Like, the nanobots that they're going to put into our bodies to cure cancer. I mean, don't think that this whole precision medicine, being in cahoots with the genomics companies and the venture capitalists and the database purveyors, along with the federal government and the universities, don't all have a connection, because they absolutely 100% do. Nano's impact on consumers. Other studies have shown that nanoparticles can penetrate cell membranes and the blood-brain barrier when ingested, damaging DNA and causing cancer, as well as heart and brain disease. For some nanoparticles used in food products like nanosilver and silica cannot be broken down by the body and could potentially accumulate and cause illness. Despite these dangers, the vast majority of nanoparticles in food have not been safety tested by the FDA or other government regulatory agencies. And if you remember, the FDA came out, just a few months ago, and it said that they don't have enough inspectors to be looking at all the food. So they're going to leave it up to the food manufacturer and the country and the company of origin to ensure that their food is safe. And like I've said before, hey, you end up with some horrible disease at some point in the future. It's all plausible deniability. How are you going to be able to prove that it was the nanotech that was in your food, or it was the GMO that was in your food? Because they're going to look at you like you're loop-de-loo and give you some sort of medication that, gets rid of your psychosis is what's going to happen. They're going to tell you it's all in your head, and it probably isn't. Actually, I found a story, it's probably already a few weeks back, talking about digestive problems, and it's stuff that I've lived through. The breakdown of my immune system from the late 90s through until probably 6, 7, 8 years ago, till I finally figured out that it was the food I was eating that was causing all these issues. Well, when you listen to Dr. Huber, and I don't know if it's in the small clip that I posted. I was actually watching this morning his entire hour-long interview. But he talks about how animals that are ingesting the GMO alfalfa, the GMO corn, that it literally kills the lactobacillus and all the other good bacteria that are living in your intestines. Well, we know now that those bacteria living in our intestines are very, very important to maintain not only proper health, but our immune systems. And then look at the scientific report that we found about glyphosate, which is Monsanto's Roundup. You're going to find that in some of your GMO Monsanto seed and food, the corn specifically, as well as some of the others. I lost my train of thought for a second. I just almost lost my headphones. We take a look at the glyphosate and that one scientific study talking about how it suppresses the cytochrome P450 enzyme. Well, if you understand how enzymes work in the body and the whole biological processes for extracting nutrients out of food, and then you listen to Dr. Huber's entire interview where he's talking about how it affects the enzymes and makes certain nutrients unavailable biologically to the organisms that consume it, you start to see a really huge, big, ugly picture. I found a scientific study on nanotech and GMO technology, and it was actually a book that Amazon had a bunch of it online, and they highlighted all the options. It happened to be a $225 ebook, mind you, that was for sale. I did not buy it, but I scrolled through everything that they had available. And Monsanto is one of the leaders in nanotechnology and development in some of the stuff that they're doing in the labs. So don't think just because they're not coming out and it's not headline news that this shit isn't actually going on. And there is nobody watching the hen house. They're just rubber stamping it all and making this a reality. So let's now hit. I'm thinking, let's now hit some of what this woman was talking about today. And honestly, I don't remember her name, but I'll look at it when I launch the video, where she's looking at some of the research in what they've been doing. And we're not talking kooky people. We're talking scientists, Dr. Cornicarn, Dane Wigington, Francis Mangels. These are people that I am fully aware of. These people are people that I trust as far as their research goes. I got to say, it is highly interesting. I've been paying attention for a couple years now. I mean, we have Dane on every Saturday afternoon, and there's all kinds of crazy stuff that's happening. I mean, Dane is probably one of the most level-headed people that I've ever known. And honestly, when I first started listening to Dane and then I met him, I was just very shocked, because Dane is somebody like me who wants proof, who looks at things from a scientific perspective, who draws conclusions based upon facts, based upon solid observations, and based upon things that he has read, studies that he's read, meetings that he's attended with world-renowned scientists. The fact that Dane believes that all of this whole chemtrail thing, and I mean, I've never really gotten into chemtrails on air, but I'm going to tell you, in the very beginning, I remember when we did that WTF show, I had suggested that maybe chemtrails had some sort of smart dust or something of that nature in it. I know that there had been speculation that Morgellons may have been coming from chemtrails. Like I said, I haven't dug into it specifically enough to be able to talk at any length about it. But I'm going to tell you that after I watched this interview or this lecture this morning, where this woman was talking about some of the findings of Dr. Carnicon and looking at under an electron microscope, mind you, and in the interview with Dr. Huber, too, that new Lifeform, quote unquote, that he said he found, he also mentioned you can only see them under an electron microscope. Well, guys, what have we learned, if anything, about nanotechnology? That it's at an atomic level and that you can only see it under an electron microscope, okay? This is where I'm seeing an exact direct correlation between all of this. So, at 26 minutes, this woman starts talking about some of the things that Dr. Cornicarn found. And actually, I think it's a little bit beyond that, because she's talking about then the different types of things that exist in biological life. And then how there's almost this like crossbreeding that's happening between these microscopic organisms that they're finding in our bodies. So I want you to hear this, because just because we're not seeing physical changes right now does not mean that it's not happening. Okay. I have friends that, unless they're seeing it in front of their face, they don't believe it. But remember, 200 years ago, bacteria didn't exist. 200 years ago, ultraviolet light didn't exist because we couldn't see it. But just because we can't see it doesn't mean it's not real. Okay, we have a very limited scope in what we can view with our physical eyes. So, all right, let me connect back up. If for nothing else, this is food for thought, but wow, I definitely need to dig into this more. Here we go.
Biology divides life into three kingdoms: bacteria, archaea, and eukarya. Bacteria and archaea are simple organisms with no subcellular compartments. Eukarya are complex with defined cell compartments and internal organelles, mini organs like mitochondria that make DNA and energy for the cell. Plants, animals, and humans are eukaryotic, as are fungi and slime molds. The archaea are the hardiest of the life forms. They're able to withstand grinding pressure, heat, acidity, and alkalinity. They can live in volcanoes, geysers, and the ice shelf. Bacteria, on the other hand, will die in extreme heat and cold, which is why we cook and freeze our food. Now, the materials appearing within these filaments are as tough as archaea. They look like bacteria, and they self-replicate. One looks like something called mycoplasma, but is not. One looks like chlamydia, but is not. And natural fibers, or filaments, would be classified as fungal in the domain of eukaryotes. But these fibers contain forms from the other two groups inside them.
So what she's saying, and she's talking about some of the findings of Dr. Carnicarn, he was finding in the fibers that Morgellon patients were bringing him, that were coming out of these wounds that formed on their bodies. Remember, they searched those fibers against the FBI database of known substances, and there was no correlation between anything that existed in that database and what these fibers were. But within these fibers, Dr. Carnicarn was finding that they contained not just the elements that exist within humans, plants, and animals, but within these other two branches of biology. And not only that, but they were self-replicating. Now, where have we heard that before? So just listen a little bit more.
You're looking at a tubular fiber with self-replicating internal elements resembling bacteria and behaving like archaea. That does not happen in the natural world.
It does not happen in the natural world.
So what are they? What's going on? It appears that within our bodies we now have all three life kingdoms replicating themselves. What does that make us? Are we still eukaryotes, or are we becoming something else? You could call this transbiology, a crossing of biology, the creation of hybrid forms. Materials are forming in our bodies that are not native to us, not natural, and entirely new. You can see in these pictures the tubular filaments with the branches. They're branching off. That's their self-replication. They're creating new colonies. And you can also see in the bottom picture a little bud. That's the beginning of a new fiber. The territory of things on the scale of atoms and molecules is the nano world. Science has opened up the nano universe, where incredible new creations are possible. Nanotechnology explores materials that are less than a micron in size, or from 1 to 100 nanometers. And a nanometer is a billionth, 1/1,000,000,000 of a meter. Nature and biology continually work on the nanoscale, assembling proteins and building with crystals to conduct the business of life. Spider webs are an example of that. Very fine filaments with enormous strength and flexibility because they contain nanoscale crystals. So let's go back to the filaments and the structures they contain, these ones that Clifford Carnicom has found. In those unidentifiable filaments, he has observed the formation of red blood cells and submicron-sized structures. So now you've got a filament making its own red blood cells. The engineered cells, the red blood, very, very tough, withstanding excesses of heat and chemicals, indicating that they are designed to endure almost anything. He has put them in a Bunsen flame, he has poured bleach on them, acid, and they still endure. In addition, they are able to replicate, growing outside of the body in a petri dish. This is highly sophisticated technology going on by itself, not in a laboratory. So we're witnessing red blood growing outside, having nothing to do with the bone marrow, in a petri dish, in somebody's very low-level lab.
Tell me if that isn't some of the scariest shit you have ever heard. And you know, as we're watching this whole evolution of medicine, where they have developed synthetic blood cells, and they have developed the ability to build, we just heard the thing yesterday about the nano DNA gel. And nanotech, one of the very first things they came up with in nanotech were these carbon fibers. You know, this back when all this stuff first started happening, when we started hearing about it in 2011, 2012, it still sounded like science fiction. But I'm telling you, now in 2015, with all of this information that's out there about nanotech, about GMO, and about geoengineering, this isn't crazy science anymore. And as I'm listening to this video actually was from January 2013, so I'm sure this was still fringe science back then. As I'm watching this now, all the dots are connecting, and it is a really scary picture. I mean, anyone ever here watch Invasion of the Body Snatchers? We were talking about that in chat yesterday. That's what this looks like.
Could it be that artificial materials are being introduced into living things? Here you have, this comes from the nanotech industry. It's what I call the nanotech pyramid. You start with materials, you go up to structures, processes, and devices. Could it be that artificial materials are being introduced into us to create new processes from the ground up, which processes will override our own natural biology, our own internal systems? People with advanced Morgellons syndrome started with fibers coming out of their skin, and they're now observing very strange crystalline forms and metallic devices. The fibers became multicolored, and now they were accompanied by plaques, strange, hard little, almost like shards. People say they're like glass, and they're colored. The lesions keep emitting these things. They don't heal over or close, sometimes for years. Here are more plaque structures, even grooved metallic devices. On the right, you'll see one device, the front and the back. These images are supplied by Jan Smith of morgellonsexposed.com, who has done extensive research on biotech websites, looking for things that match what comes out of her body. And she's finding them. The fibers from her skin were from high-density polyethylene. And I'm going to read what she's written on her website. The bizarre nature of my findings suggests a man-made source. It occurred to me that if these pathogens were being bioengineered in a lab, they were made of multiple components. The mutated material might reproduce and intermittently send out a batch of identifiable debris, much like the original genetics. I call this type of debris throwbacks. It's her theory that when new life forms are made through this gene splicing and mutation, bioengineering and nanotechnology, they will self-replicate in all kinds of ways, creating different mutations in each generation. Morgellons specimens can sometimes be identified with the original spores before those mutations occurred. Jan found 3 varieties of something called Omycota fungus in her specimens, as well as something else called Dictyostelium discoideum, which is a slime mold that is a major player in biomedical research today. The material coming from her body was ribbony and motile. It was grooved and oval, very much like the Omycota spore you see here. At the bottom, where the purple arrow from the bottom is it's a diagram of Omycota. And on the upper right, you see something that came out of Jan's body that looks exactly like Omycota. The fiber strands that you see here were made of cellulose and GNA. GNA is glucans polysaccharide sugars, and this was confirmed by microscopy. GNA is a synthetic cousin of DNA. It has a 3-carbon glycerol sugar in it instead of the 5-carbon that you find in DNA.
Now, what's so interesting about what she's saying here, I mentioned this yesterday in regards to DNA 3D printing. That's one of the ways that they were building the scaffolding, was with a certain type of sugar that they made. They would build a scaffold that would be like the shape of a kidney or the shape of a liver, and then they would use the 3D printing stem cells to print your organ. So, I mean, that stuff, that synthetic sugar is already being used in research. And if you start looking into RNAi, where they make the flagella on the back end, it's a single flagella versus a dual flagella. And wait till you hear this.
Here's a news report from April 2008 in which we are told, big headlines, GNA is DNA's chemical cousin. It's a nanotechnology building block. The Biodesign Institute at Arizona State develops the first self-assembled nanostructures composed entirely of GNA, synthetic analog of DNA. The nanostructures contain additional properties not found in DNA, including the ability to form mirror image structures. An NIH article from Japan, on research from Japan, also tells us that various conductive polymers and gold nanoparticles are entrapped within the helical superstructure of this GNA. Now, the particular sugar found in this GNA is called beta-1,3-glucans. And here you see it under what's called a Raman spectroscope, very sophisticated equipment. It looks, the microscopist who looked at this called it a sugar snake. So this is the GNA that you're looking at. When Jan's fibers were put to a high heat flame, they released what she calls a gold payload. So they dropped out this tiny little bead of gold. And here's more. The fibers that contain a head, she calls it a golden head, orbs, and they all have this payload in them. Here you have a nano array that she found, a couple of them in her body. Nano array is a tiny device used in biotech for DNA hybridization. And on the left, you see a diagram from an industry website of a nano array. And on the slide, you can see actually 2 of them. She's marked them with red X's that came out of her body, looking exactly like this. And again, I'll say it again, the nanoarrays are these tiny devices that are used for DNA hybridization. So, I'm going to repeat my nanotech pyramid. We begin with the emergence of basic filaments, followed by more complex structures. So what processes are going on here? Are these materials combining to form devices that are working together inside of?
And if we pay attention to the news that's been coming out here over the last few months, absolutely, that's exactly what they're doing. We listened to Eric Drexler. He talked about the self-assembling nanobot factories that could build things within cells. Okay, I just couldn't believe when I was hearing this, what I was hearing. All right, so from here, this goes on. I will drop you guys the full video. It is an hour and 8 minutes long, so obviously we can't listen to it here. That video started at around 26 minutes. It's titled HARP, Chemtrails, How They Change You, Bioengineering. It's pretty unbelievable. Here we go. And like I said, a few years ago, had we listened to this, I would have thought, well, it's kind of way out there. But after what we've been seeing over just the last few months, even, this does not seem crazy at all anymore. All right, I want to hop to Dr. Huber now because Dr. Huber's what started it all for me. Dr. Huber explains the science behind the new organism and the threat from Monsanto's Roundup, GMO to disease and infertility. This was an interview that he actually did with Food Democracy Now! That there was another one by Dr. Huber, Dr. Mercola. Both of those interviews are great, but the one where he talks about the new Lifeform, and he actually petitioned Tom Vilsack at the FDA to put a hold on all GMOs until it was investigated. So here, let's play this.
On January 17th, 2011, Professor Don Huber wrote a confidential letter to U.S. Agriculture Secretary Tom Vilsack, alerting him that a team of scientists had discovered an unknown pathogen. The new pathogen was found in high populations in U.S. corn and soybean crops, specifically crops that have been genetically modified to be resistant to the chemical glyphosate and the number one selling weed killer Roundup. The new organism was linked to an epidemic of plant diseases that had spread across Midwestern fields and found in cattle and dairy herds that were experiencing infertility and spontaneous abortion rates as high as 45%. Professor Don Huber is an internationally recognized plant pathologist and professor emeritus at Purdue University. For the past 40 years, he spent his career as a scientist working in professional and military agencies that evaluate and prepare for natural and man-made biological threats, including germ warfare and disease outbreaks. As a plant pathologist, Don Huber is among the most qualified scientists in the world to examine such a serious threat to America's food supply.
I'm curious why you wrote Secretary Vilsack the letter prior to the research being published.
He had a decision to make relative to Roundup Ready alfalfa. We didn't have answers that we needed in this area at the time, and when you start applying glyphosate directly to alfalfa, is it going to be similar to increasing the presence of the organism and the possibility in the alfalfa like it does in corn? If that's the case, we could very well lose the most critically important forage crop that we have for our animals. And it was a request for that funding so that we could get the answers and for him to delay a decision until the answers could be obtained. The intensity of the problem is such that we can't wait the 3 to 5 years to develop all of that research and then finally get it published.
These are preliminary results, findings that the science is still being conducted.
The animal scientists, veterinarians, it's not preliminary for them. Mm-hmm. They've very thoroughly documented what the cause of the problems are in the infertility and the spontaneous abortion situation. I had a report last week of 3 new herds one in South Dakota and 2 in Iowa. They're running 15% infertility, regardless of how many times they tried. They couldn't get the heifers to settle. And then on top of that, they were running 35% spontaneous abortion. Well, there's no way to maintain an economic viability in that type of situation, and that's what growers are finding. But in trying to find out what was causing our animal producers to go out of business, literally, because of the high mortality and inability to reproduce, that they started looking at the feed. Said, how are they being infected? Where's this organism coming from? Mm-hmm. They then traced it to soybean meal initially. Started looking at how the soybeans would be infected. And you can find it in soil, the organism. You find it internal in the mycelium of the sudden death syndrome fungus. You also find extremely high titers or high populations of this organism in soybean sudden death infected plants.
Can you tell us a little bit about the pathogen specifically?
The organism can be seen only in an electron microscope. Very small, about the size of a small virus. It's culturable. In other words, it can be grown in culture, which we don't find with a virus. It's not a prion. It's not a mycoplasma. Very small. It does replicate, reproduce itself. Very common hitchhiker with other organisms. I mentioned that it's been found in the mycelium, inside fungi. It grows very well in the presence of bacteria. It's infectious to cattle, pigs, horses, poultry. It will kill a fertilized egg in 24 to 48 hours. Animal scientists have done the Koch's postulates, that scientific process of establishing cause-disease relationship, but it's just an ultra-microscopic organism that's capable of reproduction, so it's different from a virus, very compatible with other organisms, appears to be very common in the environment, but for some reason, much higher association and colonization or population when we have the glyphosate interaction or the Roundup Ready, and especially where we see those diseases that are increased by the glyphosate, we see also the higher population of this organism.
Why are the issues with glyphosate relevant to the discussion about genetically modifying crops?
Glyphosate is the chemical name for that compound that is attributed for herbicidal action. The Roundup is a formulated product that includes other components besides just the glyphosate chemistry in order to increase its penetration into plant cells or its activity as an herbicide. When you have a genetically engineered crop that's resistant to glyphosate, it not only permits the wider use of the glyphosate, the extended exposure to it, but it also permits then the application of glyphosate directly on that crop, which many times we're consuming. What you see is that after a period of time of continued use of just one herbicide and increasing rates of that herbicide, which have been very dramatic in the last 10 years, that you see pretty soon that entire groups of organisms just cease to exist in the soil. Now, you don't have a void in the soil, so that if you pull one group out, you have another group that comes in. You have this very dramatic change in the soil microflora and that soil biota that affects these soil-borne diseases very dramatically. And that's because glyphosate is not only a very powerful herbicide, but it's also a very strong biocide, very selective in the soil, but it stimulates some of our soil-borne diseases, and it also changes the soil microflora that affects nutrient availability then for the crops. One of those critical components in that soil microflora that disappears with glyphosate or is severely suppressed are those organisms that make manganese available for the plant. When manganese is reduced in the plant, again, it becomes very susceptible to this pathogen. And so you have a biological component that is very powerful because of the powerful biocidal effects of glyphosate, and you also have a direct effect of glyphosate as a very strong chelating agent. Now, by chelator, we mean that's a chemical that can grab onto another micronutrient or other mineral element that's essential for a plant and immobilize it. And when that's immobilized, then the plant goes into a deficiency or reduced efficiency, so it becomes much more susceptible and for take-all disease as well as many other diseases.
Now, are we hearing what Dr. Huber is saying, how this works in the biology of a plant? Don't think that that's not happening to us. Now, the one interesting thing that I didn't catch before was that it causes a depletion of manganese. I wonder if it's doing anything similar to us. And it also chelates different nutrients in the body to inactivate them, which then makes you, the plant, in his case, more susceptible to disease. Well, one of the things I was reading in some of what they're doing with nanotech in foods is they're encapsulating nutrients. So they are making them available by delivering them to certain locations in the body. This is not good, people. This is the same technology. And you hear it's killing all the bioflora in the soil. But there's this other organism that's not viral and it's not a bacteria. It's kind of a, what did he call it now? He said, I think he even mentioned, well, I know I heard him before. He said it wasn't bacterial, viral, or fungal. It was kind of in between. And that woman that we heard just before said that what they're finding, their evidence is showing that it's a hybrid of all three and able to self-replicate. Both of them talked about the self-replication. Oh, do we listen to a little bit more of this? This interview is freaking mind-blowing. If you can hear the whole thing, this is probably... This little segment is about 20 minutes, but he's got a few hours worth. One with the Democracy Now! Guy, David Murphy, and one with Dr. Mercola. I highly, highly recommend that if you get time, those are two must-see interviews in understanding what we're up against, because this is the assassination of biological life. It's being replaced by something that these psychos have developed in a lab, and like we said, the genie is way out of the bottle now.
The overuse of glyphosate, or the reliance on glyphosate in the past 30 years, you're saying has created a system for soil microorganisms where certain microorganisms have been killed off or no longer prevalent. And it's allowed, inversely, it's allowed a certain other microorganisms, fungal, other type of bacteria to be present. The question is, in doing root damage is and inhibiting certain micronutrients in plant absorption, is this actually decreasing the amount of the nutrient value of some type of food crops that we're feeding to livestock, but also to human, like corn and soybean products?
Yes, in fact, my first real attention to that item was from a phone call from a veterinarian in Iowa. And he had some clients that had very high disease levels in spite of all the drugs that he was trying to give them and trying to keep them in a productive mode. And he felt like it was a losing battle. When he would necropsy his animals, those animals were dying. He would check the liver for manganese specifically, because manganese is very critical for all of our defense reactions and detoxification of the mycotoxins and those things. They were all very severely deficient in manganese.
Wow, maybe we need to look at manganese. That's pretty crazy. And the other thing I wanted to point out is listen to what he said before about the spontaneous abortions and the infertility and all the the livestock. I mean, if we look to what we've all accused the globalists of wanting to reduce the population and eugenics, this would be the perfect way now, wouldn't it? Put this shit into our food, reduce the fertility level, drop our immune systems, drop our ability to absorb nutrients, and you have a very sick, reduced population. This is just insane. And if we take a look, I was even thinking while he was talking, take a look even at those crazy genetically modified mosquitoes that we kicked all this off with a few weeks ago, the ones they're planning to release in Key West, that they also released somewhere in the Caribbean. I know they released them in Australia as well to combat that mosquito-borne disease that the horses were getting. Remember the ones that were like pterodactyls? And they ate all of the indigenous eggs. So they said somehow they killed the eggs. Well, did you hear what he was saying? That it kills anything that it comes in contact with. It actually prevents fertilization. This is all part of the same big, scary picture, and it is in our environment. So manganese, make a note of that. We need to do some big-time research into biological processes in manganese.
And he wanted to know why. Well, in Roundup Ready soybeans, for instance, there are scientific peer-reviewed papers showing that you have as much as a 50% reduction in manganese in that soybean seed, soybean feed. We see the same thing in corn, a reduction. And other micronutrients are reduced. Well, if you're feeding the same carbohydrate and that, you're assuming that everything else has kind of come along the same, but the mineral content quite often is very significantly reduced, not just for manganese, but for other essential nutrients, that then has a very dramatic effect in the food quality as well as the feed quality for those animals that are being fed. And as this one veterinarian and many other veterinarians have found, that it's not just an isolated situation, it's a much more general situation than was anticipated prior to that.
All right, and that's where we have to stop on this interview. I will drop that in the chat as well. There was one more CBS. I don't know if we can, if we have enough time to do this, but I'm going to take it right up to the top of the bumper. Oh, hurry up. Come on.
At eye-opening breakthroughs. This morning, we're learning what's next in the fight against diseases like Alzheimer's, cancer, and diabetes.
Dr. Laurie Glimsher is the dean of Weill Cornell Medical College. He's also on the board of the drug maker Bristol Myers Squibb. Robert Langer is the Koch Institute professor at MIT. Good morning to both of you. This is an extraordinary story, and because it shows you where the future of medicine is going in one aspect. So why do you say precision medicine is the future? Why don't you?
Precision medicine allows us to treat each patient as if they're a unique individual. So now that with the Human Genome Project completed, we're beginning to not only know what the genes are, but to look at their expression.
And there we go. All right, guys, it's Friday. Everybody have a beer tonight. Make sure you stick around. We got Josh live at 6 p.m. Eastern. Truth on the Tracks, the United Front Radio, 9 and 10, and then Anti-Media Live with Levon at 11 p.m. All right, guys, everyone have a great day. Make sure you check out Mr. Chuck Ocelli tomorrow night. He's got Dr. Carly on to talk about geoengineered vaccines. All right, guys, we'll talk to you later. Take care.